I found an old rotary phone. It's delightfully mechanical with the dial, bell, and handset, and I couldn't resist opening it up. And once inside, couldn't resist adding a Raspberry Pi. Adding modern electronics to a device from 1970 may seem like a waste of time, but what I found was a series of real-world challenges solved by technologies we've explored in this course. This week, let's solve the problem of how to ring the phone bell. Hi, I'm Mark Neiman Ross, and welcome to this week's edition of Raspberry Pi Weekly. Every week, we explore the Raspberry Pi and share useful tips. A standard rotary phone operated at 90 volts with a 20 hertz signal. That's a lot of voltage for just a ringer. Instead, I've removed the old electromagnet and replaced it with a 5-volt solenoid. I glued a wire crimp terminal to the end of the solenoid and then bent the fingers of the terminal so it would grab the ringer arm. The solenoid is glued in place with superglue. On the breadboard in the phone, I reproduced the transistor circuit we covered in the earlier Raspberry Pi video on controlling more than 3 volts. The handout for this chapter includes a diagram of the circuit. For battery power, I'm using a battery charger with a USB connection to the phone. This provides 5 volts. The programming to drive the bell is simplicity itself. I'm using the buzzer method from GPIO 0 and connected it to GPIO 23. The buzzer method allows me to control the speed of vibration and the number of times the ringer rings. In this case, it'll turn on for 0.04, turn off for 0.04, and it'll ring 20 times. When I run this program, the phone rings. I was delighted at how easy this project was to implement. It's helpful to know how to create a transistor circuit and program the GPIO. Thanks for joining me for this episode of Raspberry Pi Weekly. Be sure to join the LinkedIn group and check out previous episodes on LinkedIn Learning. I'll see you next week with more Raspberry Pi adventures.